so on. This is only for this interval of x. So if somebody asks you ln 1 minus x, so you just replace x with minus x here, and similarly here also. Right? The sin x is x minus x cube by 3 factorial plus x5 by 5 factorial, so on. Cos x is 1 minus x square by 2 factorial plus x4 by 4 factorial, and so on. A way to, when does limit exist? When do we say that limit exists?
When all three are equal.
Yes, all three are equal. Correct. Mm, and here actually, they'll give you some piecewise functions also. Definitely they will give, if because most of the piecewise functions are they actually don't satisfy this property. Okay. Some questions actually you will see that you have to use expansions. So let me make you write them. Ex is 1 plus x by 1 factorial plus x square by 2 factorial plus so on. Ln 1 plus x is x minus x square by 2 plus x cube by 3 minus so on. This is only for this interval of x. So if somebody asks you ln 1 minus x, so you just replace x with minus x here, and similarly here also. Right? The sin x is x minus x cube by 3 factorial plus x5 by 5 factorial, so on. Cos x is 1 minus x square by 2 factorial plus x4 by 4 factorial, and so on. A way to remember these two is, see, do you can you like tell me if you have seen this thing being used anyway, that when x tends to 0, or let's say you have sine
Mm-hmm.
theta, when theta tends to 0, do we assume sine theta as just theta?
Yeah.
And similarly, when theta tends to 0, we assume cos theta to be just 1.
Mm-hmm.
So that's why somebody might get confused between what's the first term here. So that's why for cos x you have 1 and sin x you have x.
Yeah.
Okay. Then for tan x it's x plus x cube by 3 plus 2 by 15 x5, so on. Uh, this is actually, you can see how the coefficients are very random. So only till here you need. Then
Okay.
finally you have 1 plus x, 1 by x. E 1 minus x by 2 plus 11 by 24 x square. Similarly here also coefficients are random. You only need till here.
Okay.
And all of this is derived from Taylor Maclaurin series, these related things, but that is not part of our syllabus. You can just keep them in your head.
Could you go down a bit?
Yeah, down. Okay.
Yeah. Just 1 second. Yeah, got it.
Okay. Uh, Now some standard limits we can do. Standard limits. Okay. Okay. Let me first make you write this, and I'll tell you what's the approach of maximum questions. So sin x by x, limit x tends to 0. LT or LIM, I'm writing it's the same thing, only it's limit. I use this. Okay, all of this is one only. Can see how this is actually a special case of this only, where here you put a as e. Okay, this much I think is good. Uh,
Mm-hmm.
can do few more. Example, limit x tends to a, xn minus an, x minus a, n a n minus 1. See, you put a here as 1. So do you get a special thing which is like this? I mean, not special, but I'm not making it right for just for this. I can see. Okay. So here it's either plus or minus infinity, both. For both it would work. This is, the all of these things are just for speed solving actually. I would say remember this. But you don't even need to remember this. You don't need to remember any of this. What happens is, let's say you encounter this thing, you don't know what it was. Nothing. You see how this is a case of 0 by 0 only. You put x as 0, you get 1 minus 1 by 0. So yeah, it's a 0 by 0 case.
Yeah.
I'll just differentiate it. So it's ex upon 1. I put x as 0, I get 1 as the answer. So yeah, it's matching.
Yeah.
Okay. uh One thing. See here, you see how limit x plus minus infinity is being involved here. A very great practice in limits is to use the idea of substitution. Generally, we want to deal
Mm-hmm.
only with whatever the variable is there. Let that be approaching 0 and not anything else, right? It should not be approaching 2, 5, infinity. Let's say you see that, okay, it's approaching to 2. A better idea is to, and generally the question also will give you hint, let me bring this to this side. So now my t minus 2 is approaching to 0, and let me assume this as some variable. And the questions are also in that thinking line. You will see that, oh, t minus 2 is being used somewhere in the question. So if I assume it as some variable, let's say x, two things are being worked upon. One is that I'll be evaluating it approaching to 0, which is a good thing. And my question also gets reduced because I'm using substitution. Do you realize this?
Yeah.
Very important idea. Uh, okay. So you can see how whenever you have, let's say here you have, let's say x tends to, let's say, infinity. I will just take a variable as, let's say, 1 by x as t. So now my t tends to 0, right? I'll replace
Mm-hmm.
x with 1 over t in the entire question.
Yeah.
Okay. Do you remember there were some standard limit on cos x also, right? 1 plus cos 1 minus cos 2x, 1 minus cos theta by 2x, something like that. That used to be 1 by 2 and all of those things.
Yeah.
Yeah, I have not written that because again, uh, anywhere you see something like that, now, for example, let's say 1 minus cos theta is 2 theta, limit theta tends to 0. What is this form? Is it 0 by 0? Yes. Let me just differentiate it. So cos theta derivative is what? Minus sine theta or sine theta?
Yeah.
Minus
Uh.
sine theta.
Yeah.
Okay, so that's this. So probably I've made a mistake here. What was it? Okay.
Won't is
Yeah.
isn't this U by V format?
Yeah. So what? You want to use that u by v quotient rule?
No, no, no. 1 second. Okay. No. Yeah. I
whenever
got it.
we use we use LH rule, we differentiate the numerator separately and the denominator separately. We
Yeah,
don't
yeah, got it.
use, yeah. I am just, you know, thinking about that standard limit because okay, it was 1 minus cos theta by theta square, limit theta tends to 0. Let's say I don't know the standard limit of this, so nothing, this is 0 by 0 only. I'll just differentiate sine theta by 2 theta, so it's cos theta by 2. So is this 1 by 2? I put theta as 0, right? So you don't need to remember any of it, as honestly, so it's okay. Now again, very important thing, algebra of limits. So let's say you're multiplying it with a scalar, you can bring that scalar out, right, and apply the limit operation on just this thing. Let's say you have plus minus or multiplication with another function, so you can very well handle both of them separately, given that each one of them is individually, like any one of them is not becoming individually not defined. Let's say you separate them and you are seeing how when you're evaluating the limit, this is giving me infinity, so that's wrong. What you should do is, rather than testing them individually, combine them and then, so don't separate them via this operator. Do you get this?
Yeah,
Yes. Another is f by g. Let's say here also you can, you know apply separately, given that this limiting value of this at whatever x, whatever variable, whatever, should not be 0, right? So that means limit gx x tends to a should not be equal to 0. Obviously that's a fundamental rule, right? Division by 0 not possible. Now very important thing, like this is actually the most important of all of them. See, if f is a continuous function, if f a continuous function, you can directly go inside f and apply limit on the gx only. Very important thing. uh they have asked this very times, even in your JEE advanced, or let's say by JEE means also. Let me give you an example here. Have you seen how sometimes while evaluating limits, you go inside this whatever the power of e is, and you apply it
mm-hmm.
here, and then whatever you get answer as, you report the answer as, let's say you get answer as 2, so you report the answer as e square. So basically you went inside the power of this. Why? Because e power x is a continuous function, so you can assume it how it's a chain inside a chain, like basically composition of function. For example, we can say, let's say we have efx. So do you realize how this is a composition of function? How, let my base function be fx, which is e power x, gb fx, oh sorry, hb fx, sorry, let this be g. Okay, can you see how this is nothing but what is this, g of h, correct? Or did you not get this?
Could you just repeat one?
Yeah. So if we see this function e power fx, this is actually composition function inside a
Yeah,
function. How? Let's say my, ignore this, let's say my g of x is e power x, and let's say my h of x is f power x. Can I write this
mm,
thing as g of h of x?
yeah,
Because it would e power f of x, right? And can you see how g is a continuous function here? E power x is a continuous function, right? Something like this.
yeah,
Yeah. So that's why we go inside the power of this and then evaluate it there. Limit. This is just one example. Generally, in our context, they have majority, they have used this on E only. But let me tell you, in I think 2022, they once used it on sine function also, right? They gave you a function fx. Yeah, that happened in J once. They gave you function sine x, they gave you function gx, something, and they were asking this limit, right? So the first part to solve this question, right, was to that this is a continuous function.
Many students practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.